In 6.4, we're going to cover the triangle mid-segment theorem. And as with everything else, we need to learn the vocabulary that goes along with this theorem in the first place. So what is a mid-segment? A mid-segment is a segment that connects the midpoints of two sides of a triangle. So again, it connects the midpoints of two sides of a triangle. Every triangle has three mid-segments, okay? And when I connect, or when you connect all those mid-segments together, you're going to see that it forms a mid-segment triangle. So again, what we have to think about is how did this thing start? Well, this started with this black outer triangle, okay? We started with triangle ABC, okay? That was the three sides of the first triangle. And then what we did is we took the midpoint of AB and the midpoint of BC, and we drew a line connecting those two midpoints. Then they found the midpoint of AC rather, and they drew this line and connected those two mid-segments. And then they found, again, the midpoint of AB, and they connected the midpoint of AB and the midpoint of AC. And when we connect all those midpoints, again, you notice that it creates a triangle. Now, the midpoints alone, once we know that point M is the midpoint, obviously we know that we now broke these AB into two congruent segments. If P is the midpoint of BC, we know these are two congruent segments. And if N is the midpoint of AC, we know AN is going to be congruent to NC. So all those pieces are congruent. And then we have this mid-segment triangle. So we're going to move to the next slide to see what we can conclude from that mid-segment triangle. So once you have that mid-segment, down and you understand what it is, now we have the mid-segment theorem. The mid-segment theorem says that the segment that connects the midpoints of two sides of a triangle, in other words, the mid-segment, is parallel to the third side of the triangle, and it's half as long as that side, okay? So what it's saying is, so when it says the segment containing the midpoints of two sides, well, what this is really referring to is the mid-segment. That's the segment that contains the midpoints of two sides. So when I come over to here, I know that the mid-segment, again, if I come over to here and I find the midpoint of AB, the midpoint of BC is E, and if I draw this line connecting the mid-segment, this line is going to be parallel to the third side, so I know that DE has to be parallel to AC, which is great. That's really important information. And on top of being parallel, it's half as long as AC. So if AC is 10 units long, DE is 5 units long. So again, I come over to here. So this theorem gives us really important information. So if DE is the midpoint of ABC, or the mid-segment rather, I know that line DE is parallel to line segment AC, and I know that DE is going to be half of AC. I'm also going to know a lot of important information regarding angles now. I know we're not going to talk about that much here, but again, remember, once I know that two lines are parallel, okay, then we know that, for example, corresponding angles are congruent. So this angle and this angle would be corresponding. And again, that just is really cool because now we can get and gather more information. So not only do we know the lines are parallel, but we know the top line or the mid-segment is half of the line it's parallel to. And then eventually we're going to work with angles as well. So again, it says triangles are used for strength in roof trusses. We've talked about that before, how triangles are very sturdy and we use them a lot in construction. So in the diagram, it says that UV and VW are mid-segments of triangle SRT. It wants me to find the length of UV and RS. So again, I need to come over to here and I need to kind of understand the original triangle that we're working with. Notice the original triangle is this large triangle here. okay? And this large triangle has vertices S, vertices R, and vertices T. And it says, first of all, that UV is a midsegment of the triangle. So I'm going to start with UV. I'm going to focus on one midsegment at a time. So this midsegment here, that means, obviously, that it starts at the midpoint of SR and the midpoint of ST. I also know that my midsegment is parallel to RT, because I know that's one of the things of the theorem, and I know that UV is half the length of RT. So when I go to UV, when I go to UV, I know that it's half the length of RT, and in this case, RT, we're told, is 90 inches, so I know UV is 45 inches long. So line segment UV is 45 inches. So this here is 45, okay? Because again, it's half of RT, which is 90, okay? So that's one thing that I found. Now, of course, I'm going to erase that, and I'm going to work on the next thing that they told me, okay? The next piece of information that they gave me was in the problem. They gave me that RS, or it told me that VW was a midsegment as well. So again, I'm going to find VW. Well, here's VW. It goes from this midpoint to this midpoint here. So here's this line down here. And so again, VW is my midsegment. I know that VW is parallel to SR, okay? And I know that it's half of whatever SR is. Well, notice that it told me that VW is 57 inches. So again, I'm going to come over to here. VW is going to be, this is a V, okay, is going to be half of RS, okay, or SR. VW is 57. Well, 57 is half of whatever RS is. If I multiply both sides by 2, I'm going to get 2 times 57 is 114, and that's going to equal the length of RS. So RS is 114 inches. Because I know, just like I know VW is half of RS, I know RS is twice VW. So I can double VW and get my missing piece of information. So take your time when you do these and make sure that you are being very careful about which midsegments you're working with and which is the side that's parallel to it and which is the side that is double the midsegment, or which midsegment is half of the side. And again, now we're just going to come over here and complete this table. And again, notice that what this is doing is we have this original triangle. We have triangle ABC. It's this yellow triangle here. And they created a mid-segment triangle. And so again, what that means is, remember that every midsegment is half of the side that it's parallel to. So I'll start with this one in A. It says that AB is 12 units long. So that means from here to here, this entire side is 12 units. BC is 14 units long. So this whole side is 14, and AC is 18 units long. Okay, so I have my 3 sides of my yellow triangle. Now it wants to know what is ST. Well, again, I'm going to come over to ST. ST goes from this midpoint to this midpoint. So I know that it's parallel to AC, and I know it's half of AC. So if AC is 18, ST is 9, okay? Now I go to RT, so I'm going to erase ST, okay? I go over here to RT, and I know that RT is this, or no, not that one, sorry. RT is this one, and so I know that it's parallel to AB over here. And I know that it's half, so if AB is 12, RT has to be 6, okay? And then lastly, they want to know RS. So again, I'm going to erase RT, and I'm going to go to RS. And RS here, again, RS here is going to be parallel to this third side, BC. I know it's half of BC. If BC is 14, RS has to be 7. And so that's how I find my mid-segments. Again, I'm just going to kind of erase everything. You can go back and look at it if you want. And I've got new information for problem number 2. In problem number 2, it tells me that BC is 15. So again, I might even do this. If BC is 15 from here to here, okay, is 15, then I know RS is going to be half of that, which is 7.5. Okay. If I go to the next one, they tell me that AC is 22. Again, AC goes from here to here. My mid-segment is ST. So if AC is 22, I know this is 11 because it's half of it. So it's half, it's 11. And then the last one, again, the last given, they didn't give us AB, but they did give us RT, which is 10. So they said this unit right here, this little mid-segment is 10. Well, that means obviously the side parallel to it is going to be double it, or 20. And so there you go. You have all your missing pieces. And again, we'll go to the last one and we'll do the same thing. So if they give you the mid-segment, double it for the side. If they give you the side, half it for the mid-segment. So if AB is 10, again, this side is 10, then the mid-segment that goes with it has to be 5. So RT is 5, okay? If they then gave me ST, so here's ST, that's a mid-segment, and they told me that ST is 9, well then I know that AC, which is parallel to it, has to be twice as much, or 18. So AC is 18. And last but not least, they told me that RS is equal to 7.8. So if RS is equal to 7.8, right, that means this unit, or this segment, mid-segment, then we know that this line here, this side of the triangle that's parallel to it, is going to be double the 7.8. So it's going to be 7.8 times 2, which is 15.6. And so that's the answer to that one. So again, once you know the rules, obviously then the rest is just different types of problems using the rules. But again, you always want to ask yourself, what was the original triangle? And as you can see here, your original triangle is this, you know, HGJ triangle here, okay? And then obviously the mid-segment triangle is ABC. So it's telling you again, use triangle GHJ where ABC are midpoints of the sides. If GH equals 7x plus 1, so GH again is this entire side, and BC is 4x minus 3, so this piece right here is 4x minus 3. What is GH? Well, again, remember that BC is going to equal half of GH. Okay, that we know because BC is the mid-segment that goes with GH. So if BC equals 4x minus 3 and GH equals 7x minus 1, if I do the math correctly, I'm going to be able to solve this problem. So I'm going to distribute the half. I'm going to get 4x minus 3 equals half of 7x is 7 over 2x minus, and then a half times negative 1 is minus a half. Notice I have this denominator of 2. A lot of you might have noticed that at the beginning. If I multiply every term by this 2, I know that I'm going to be able to cancel that denominator, and that's going to be easier math for me. So 4x times 2 is 8x, minus 3 times 2 is 6. If I multiply 2 times 7/2, I just get 7x, and if I multiply 2 times a half, I just get the minus 1. And so notice I have no denominators now, and this is much easier to work with. So I'll subtract 7x from both sides. X minus 6 equals negative 1. I'll add 6 to both sides, and I'll get that x equals 5. And so again, I've got x. And I know we love to find x and say that we're done, but again, notice that it's asking me for GH. And again, in this case, GH was told to us that it was 7x minus 1. So 7 times 5 minus 1, 35 minus 1, or 34. So GH equals 34. And so that's the answer we wanted. So again, if I ask you for BC, well, I know BC is half of 34, so I know it's 17. Okay, and so again, that's really how we apply the mid-segment. Just make sure you make your note cards and you're trying to keep track of the differences, because now we've really dealt with a lot. We've dealt with perpendicular bisectors, we've dealt with angle bisectors, we've dealt with altitudes, we've dealt with medians, we've dealt with just now we've dealt with mid segments, and I can't even think of what else, but it's a lot. So make sure you're keeping track of everything. Individually, they're all quite easy. It's when you put them together that they start to get mixed up. So you need to work on memorizing all of these things we've been learning in Chapter 6.